Okay, so this is our lesson. We're going to continue on subatomic particles, which, as you recall, are the small components of an atom. We actually have three main subatomic particles. As you can probably remember, we have protons, which carry a positive charge, and then we have neutrons, which are neutral. They carry no charge, and then we have electrons, which we are going to cover in a little bit more detail here in a second. And as you recall, those carry a negative charge. So it's important to keep that in mind: protons, neutrons, and electrons. We actually had a scientist. He was Danish. He was from Denmark in 1911 all the way up to 1921. He had his research on the atom. His name was Niels Bohr. And maybe you're familiar with the Bohr model of the atom, or the Bohr atomic model. And that's the one you've probably seen in books, on television, in shows, magazines, even in cartoons. You've probably seen the little atom, the little round center, the nucleus, and it has a little electron spinning around it, kind of like the logo. If you've ever watched a show like Jimmy Neutron, you remember that that was the model that you thought was how the nucleus of the atom looked. And that was actually developed kind of with a foundation based on what Niels Bohr researched. Now, what we found out later on, and this was a long time ago, of course, as you recall, this is like 1920s, Niels Bohr's model was actually only really compatible with the hydrogen atom, the first element. And although he was partially correct, or mostly correct, it could not apply to the rest of the later on discovered periodic table. So it was important to come up with a model that actually applied to all of them. And what we call a model is a representation or a picture of what we think the atom and the subatomic particles look like. Of course, they are microscopic, they're tiny, they're invisible to the human eye. So it's just an idea of what we think they possibly look like. So later on, we actually had two different scientists, and they were French and Austrian, and they came up with something called the wave mechanical model. And that's different in the sense that it could be applied to all of the particular elements that were discovered later on. What was false, or what was wrong about the first model was, as you see, there's a nucleus in the center, and then there are electrons that are revolving around it in fixed proportions. And that's not actually true. The wave mechanical model, which was developed by those two scientists later on, actually predicts that the electrons, which are revolving around the nucleus, don't actually have a specific route or orbit. They're not spinning as you can imagine them from that diagram that you can see in your head. They're actually just going around in random locations, in random spaces, in random motion. We do know for a fact that electrons revolve around the nucleus. We just cannot calculate at what distance and in what space they are at a given time. You can't predict exactly where an electron will be at a specific time. And that's actually neat, because it shows us our creator, it shows us the God that put design into something so small as a nucleus of an atom. It's minuscule, microscopic, and he still does not allow us to predict where an electron will be at a specific time. And I just think that's something that he wants to leave unsolved, so we can rely on him for more knowledge when it comes to science. So I just want to remind you that at the center of an atom, of course, there is a nucleus, and we have protons and neutrons inside the nucleus. You got protons and neutrons inside the nucleus. The electrons are revolving around it. We don't know exactly their motion and where they're going to be at a specific time, but we do know that they are revolving around the nucleus. So the lesson is on electron configuration. That's what it's called, electron configuration. There is a lot of material, a lot of facts, a lot of knowledge that has to be retained on this, and I've reduced as much as possible for the first video. We're going to go in a little bit more detail later on in future lessons, but this is just a brief overview of electron configuration. Now, the one thing that I would always advise for you to have, just like in many other lessons, is to have out your periodic table. This is important. You actually need to look at this in order for you to understand the order in which electron configuration goes. It's important. At the beginning, you're going to see it's just a bunch of random numbers and letters and even more numbers. And it's really going to confuse you if you're not looking at the table. So I want you to take out a periodic table. I did send one home last week, one that has these numbers underneath it. You can use that one, or you can use any periodic table you can find. I've given you multiple copies. You can find one online. You can print one out. You can use the ones I've given you. It doesn't matter. You just need to locate different elements on the table, and then it'll make sense. So we'll start from the beginning. These two scientists that came up with the wave mechanical model started off by giving us something called a principal energy level, as you can see in the top left. That is called your principal energy level. These terms are important. You might want to write them down, take a picture, or remember them somehow. Principal energy levels are described by what we call quantum numbers. Quantum numbers are used in science, and they are to signify different energy levels. So these right here are quantum numbers. Now you can look at them as random numbers 1 through 4. In science, for the purposes of describing energy levels, we call them quantum numbers. Generally speaking, there are 4 principal energy levels when it comes to electrons. 4 principal energy levels. That's important for you to remember, that they are called principal energy levels described by quantum numbers. These are your quantum numbers 1 through 4. 4 major principal levels of energy. Remember that. Then you also have 4 sublevels. So you have a principal energy level, you have 4 of them, and then you have 4 sublevels. These are also known as orbitals. I do have to tell you that although the word is called orbitals, they are not orbits. These are the motions of the electrons revolving around your nucleus, but they are not in orbits. They are called orbitals, but they do not orbit. Like the planets around the sun, there's not a specific route that they take. They can move in any motion that they want. We do know, though, that they are revolving around our nucleus, which is the center of our atom. The sublevels are represented by letters. These are important letters for you to remember. You have S, that's your first one. You have P, that's your second one. D, that's your third one. And then F, that's your fourth one. You have S, P, D, and F. Once again, your 4 sublevels when it comes to electron configuration are S, P, D, and F. 4 letters. Then you'll have to remember that every sublevel can have a maximum amount of orbitals. That's our next step. So your sublevels are S, P, D, and F, and then each one can carry a certain amount of orbitals. S always has only one orbital. P always can have up to 3. P can have up to 3. D can have up to 5, and then F can have up to 7. As you can notice, the higher the principal energy level goes, the more excited, that's the term that you use, the electrons and the energy becomes. The S1 is the ground level. That's the least amount of energy being produced by the particular element. This will make sense later on. Just remember these terms, the order, and it will make sense. So once again, principal energy levels, you have 4 of them. 4 principal energy levels. They're described by quantum numbers. You also have 4 sublevels, each described by a letter, S, P, D, and F. This is the maximum that they can have. And notice how they just skip a number. If they skip a certain amount of numbers, and that's easier for you to remember. So it's 1, 3, 5, and 7. They skip a number. They skip 2, 4, and 6. They're all odd numbers, 1, 3, 5, and 7. Then the last thing I need you to remember for this first part of the lesson is that every orbital can carry up to 2 electrons. And that's very important for you to remember. Probably one of the most at the top of the list of things to remember about this lesson is every orbital can only carry up to 2 electrons. It can carry 1 or 2, no more than that. Which means that technically the S orbital can carry 2 electrons. The P orbital can carry 6 electrons because it's 3 times 2, 6. This can carry 10 because it's 5 times 2. And then this can carry 14 because it's 7 times 2. So each orbital can carry up to 2 electrons. So remember, principal energy levels up to 4, sublevels also 4, represented by letters S, P, D, and F, and then each one can carry up to 2. You multiply it by 2, that's the maximum it can count. Now, then looking at the model of the electron configuration. So when you write electron configurations, it's going to look something like this. You can see here at the top, if you notice on the periodic table that I sent last week or a couple weeks ago, it has every single element with letters and numbers right underneath it like that. I also sent out a packet where it has every single element in the front and it just looks like a whole bunch of letters and a whole bunch of numbers. That is something you might want to take out so you can follow along. So this is the one for hydrogen because it is the simplest one. I will show you. We're kind of very simply, very quickly going to dissect what each little component means, and then it will make a lot more sense. So what you're going to have is you're going to have a big number, you have a letter, and then a little number. We're going to describe it like that. Big number, letter, little number. That is how electron configurations look at the beginning, the basic levels. So the first number, this is something you might want to write down, take a picture of, remember, whatever is necessary for you to understand it. My big number is my quantum number, That is going to tell me, once again, what level I am in, quantum number. So hydrogen is in the first principal energy level. The first one. It's the first element. If you remember, it's also the first one in my electron configuration. This is under the principal energy level 1. Then my letter is going to tell me the sublevel. Obviously, my first letter is S. By the way, the letters describe the shape of the particular orbital. For example, the S is for spherical. So all of the electrons in the first sublevel actually look, or we are predicting that they look like a sphere, which is a ball. It's round. Then my second one, which is P, describes a different shape. It is two-lobed. And it's actually the further along you move along the letters, the more lobes it has. So what we would think the particular shape and the particular orbital of an electron actually changes and multiplies, and it looks a lot different than what we imagine. You can actually look at that in your book if you'd like, and it shows you the different shapes of the particular electrons. That's what the letter stands for, the shapes, the sublevels, and then the shapes. The shapes aren't as important more than actually how the orbitals are filled in. And we'll talk about that here in a second. So the letter is going to tell me the sublevel. Then the small number is going to tell me how many E for electrons. How many electrons are there in the particular element? Now, this is kind of like a shortcut, and you'll notice it more in the further elements. If you count the little numbers at the top, that is going to tell you what element it is. So it'll tell you that you're doing this right. Now, if you count the numbers here at the top, notice how there's just one. That's it. What's element number 1? Hydrogen. So you know that this is the electron configuration of hydrogen. It's very simple. First level, 1 electron. That's hydrogen. It's as simple as it can get. Now let's look at a couple other ones. We're going to skip hydrogen. I'll show you that here in a second, how that's used later on. Let's look at lithium. Locate lithium on your periodic table. Need you to look for it in order for you to understand where it's at. If you remember, it's element number 3. It's actually the first one though in the second row. And the rows are going to be very important for your electron configuration. For this lesson and for the next couple of lessons, you need to notice what row they are in. Notice how hydrogen is in the first row, and there's only 2 elements in the first row, hydrogen, and all the way on the other side there's helium. Notice how lithium is already in your second row. That's important. It's going to make more sense later on. So locate lithium, and then what's going to happen is you're going to write all of the electron configuration before it, which basically means that you're going to have to copy everything from before. So if lithium is number 3, you have to copy hydrogens, which is this. You're going to have to copy heliums, which is the next one, and then lithium. So let me actually show you the helium one so you can understand. So let's look at He, which is helium. Once again, it's in the first level. Let me give you another tip. The row that it is in is going to tell you the principal quantum number that you're going to use for the first energy level. So once again, remember how helium is also in the first row. So your big number is also going to be 1. Remember that your first sublevel is S. You're going to use S once again. But remember that every single orbital can carry up to 2. Tells you right there at the bottom. This one only has 1. So before you can move on, and this is one of the 3 rules we're going to learn about when it comes to electron configuration later on. This is in the next lesson. But before you move on to P and D and F, your levels before it have to be filled. So before I move on to P, D, and F, once again, I have to fill in this first subshell. And remember, it has to have up to 2. So this one only has 1. In order for me to fill it, I have to put a second one. So this is actually my electron configuration for helium. Once again, that is for helium. First energy level, the first sublevel, 2 electrons. Remember I told you can count the little number at the top to tell you what element it is. Notice how it's just 2. Therefore, what's element number 2? Hydrogen, helium. Helium is the second one. This